Hello and greetings. In this lesson, we're going to get familiar with the inputs and outputs of a PLC. For a PLC to be able to interact with the outside environment and execute the program we've given it, it needs us to provide it with some information from the outside. For example, we might give it the command to turn a device on or off, or tell it what the temperature is, or provide it with some information from other equipment. Now, to do this, the PLC provides us with an input terminal, and there are 4 ways we can give this information to the PLC. 1. Digital signal. 2. Analog signal. 3. Pulse train. And the 4th method is network. Now, what are digital signals, analog signals, pulse trains, and networks? Stay with us as we go through each of these one by one. To provide information to the PLC, the first method was the digital signal. What do we mean by digital signal? Signals that are either 0 or 1, or to put it simply, they are either off or on with no in-between state, like a switch, like a normally open push button or a normally closed push button, which are either off or on. These types of signals are called digital signals, and in H-series PLCs, digital inputs are represented by the letter I. As you can see in this model, it ranges from I0 to I15. If you remember from the previous lesson, we said that the digital inputs of H-series PLCs are either 16 or 32 in number, and they can be activated as either sync or source, which we will explain in detail in the next lesson. The next method was through analog signals. Signals that are continuous or cover a range of changes and are not just 0 and 1 are called analog signals. Analog signals are like pressure, temperature, or humidity. For example, temperature doesn't jump from 1 degree to 2 degrees instantly. It goes through a range of temperature changes. For example, it goes from 1 to 1.1, 1.2, 1.3, and keeps changing continuously until it reaches 2. So, signals that change continuously like this are called analog signals. The H-series PLC does not have analog inputs on its own, but we can add them to the PLC using an option card, and usually analog input option cards start with the code XBF. For example, the XBF AD04A, which specifically has 4 distinct analog inputs, or the XBF RD04A, which is primarily designed for RTD sensors, offering precise temperature measurements, or the XBF TC04S, which is specifically designed for thermocouples, or the XBF LD02A, which is utilized for load cell inputs. All of these important modules we will thoroughly explain to you in great detail in the upcoming lessons related to analog inputs. The next method is through pulse trains. In fact, a high-speed counter that can count the number of pulses we give it, which we refer to as a high-speed counter. Where are these pulses generated from? There are various methods, such as the output of an encoder, a pulse drive output, or any other equipment that generates pulses with a constant amplitude for us. In our H-series PLC, we have 8 high-speed counter channels. 4 of them are 20 kHz and 4 are 100 kHz. We can connect these to the first 8 digital input terminals, that is I00 to I07 of the PLC, and in the programming we do with XG5000, we can define those inputs as high-speed counters. The next method is through networking, where we can share information and data from multiple devices with the PLC or send commands to the PLC via the network. In the previous lesson, we mentioned that the H-series PLC supports RS485 and RS232 networks under the Modbus protocol. As you can see in the image, the positive 485 and negative 485 terminals are related to the RS485 network, and the TX, RX, and SG terminals are related to the RS232 network. Now, what happens when external information enters the PLC through one of the 4 methods we discussed? According to the program we wrote for the PLC in XG5000, the PLC carries out the necessary actions and transmits the required commands to the outside and to the intended equipment through its outputs. These outputs, just like the inputs, can be in the form of digital signals, analog signals, pulse trains, or network signals. Just one point about digital outputs that I'd like to mention. In the H-series PLCs, digital outputs are represented by Q, and as you can see in this model, they range from Q00 to Q15. These digital outputs come in two types: relay and transistor types, with the transistor model being connected in two ways: PNP and NPN, which we will explain to you fully in the next lesson. But as for analog output, the H-series PLC does not have analog output built in, but we can add it to the PLC using an option card. There are two types of analog output cards. One is voltage type, the other is current type. Analog output voltage cards are identified by the code XBF-DV04A, which comes in various codes, but the DV after the dash indicates that the analog card is voltage type. And if instead of DV it says DC, then the output card is of the current type. But positional outputs, which are mostly used in positioning and position control applications. In H-series PLCs, the outputs Q00 to Q03 are used, where Q00 and Q02 outputs are related to the X-axis, and Q01 and Q03 outputs are related to the Y-axis.